Ginawa niya lang pero hindi pa na-describe. So, basically, sa histo techniques, ang ginagamit natin ay H&E, right? Yung pinaka-common. So, the two structures you always want to look at are your nucleus and your cytoplasm. So, marami na parts ng cell. Kung so structural to, you have your cytoplasm, the Golgi complex, the mitochondria, the reticulum, nucleus, chromatin, and heterochromatin. Okay, ano niya yan? So, the nucleus, okay, depending on its stage, is cell division. Diba meron tayong interphase, prophase, metaphase, anaphase, and telophase. So, depende kung nasaan siya. And, often, using H&E, you get a membrane-bound dark blue-purple mass. Okay? So, nucleus, right? Remember that? Nucleus siya. Nucleus yan. Nucleus. Ganda, no? Okay. The nucleus, seen on H&E, has the nucleolus. Okay? This is usually intensely basophilic. Okay? But with very good H&E, it could appear acidophilic. Okay? And your nucleolus is basically important for protein synthesis. Ano nyo yan? Wala. Okay, the chromatin stainable, you have your heterochromatin and your euchromatin. Sino ang active? It's your hetero. Your euchromatin is resting chromatin. Okay? So, okay, this is the brain. Ito yan. Nucleolus with a nucleus, cytoplasm. So the cytoplasm, okay, amount of appearance is very important to what type of cell o pinag-uusapan natin. So you can have your free ribosomes. Nakikita mo to, basophilia of the cytoplasm. Okay, the ribosomes basically your RER. Kasi yung SER, di ba sa fat? And remember, hindi na stain ang fat, right? So endoplasmic reticulum, okay, it could be granular, again, basophilia. Ang hematoxylin is a basophilic stain, right? It attaches to acid-based substances. Ang eosinophil is acidic, therefore it attaches to basic. Ano yan? Staining pattern. Okay? So, nakita niya, this is a plasma cell. Tingnan niyo ang kanyang cytoplasm. Okay. Reddish, tanipotin, blue. Kasi, what is your plasma cell for? Ano ang function ng plasma cell, class? Patapos na tayo sa semester, what's the function of your plasma cell? Production of anti-coagulant, antibodies, and your antibodies are basically protein-based. Okay? Kaya mapulan sa cytoplasm nila. So, this one, okay, this is your pancreas. Nakita niyan? Look at the nucleus, look at the cytoplasm. The cytoplasm is granular. Remember, the pancreas is important for secretion of what? Insulin, what else? Lipase, amylase, those are all enzymes, basically proteins. So, within the cytoplasm, kita niya granular, bluish granular. Okay? So, staining mechanisms, it actually uses two, no? Meron tayong physical and chemical, and most things depend on absorption of dye. Okay? Now, merong mga bonds na nangyayari. You can have your ionic bond, covalent bond, van der Waals, hydrogen bonds. Okay? Those are important bonds. So, the staining mechanism, basically, we can stain cytoplasm by developing a positive charge on the cytoplasmic proteins and a negative charge on the dye. So, unlike charges, attract. Like charges, repel. Tandaan yan. Simple lang to. Acid-based lang ito. Acid-based lang. Ganun lang. Pag acidic yung isa, dapat ang kunin niyang stain, basic. Pag basic yung isa, ang kunin niyang stain ay acidic. Ganun kasimple lang. Okay? So, hydrogen bonds, basically hindi siya ganun kaganda kasi water water na to, water-based. In anything water-based, pag nag-evaporate ang water o that moist, nawawala. So, kasama siya, pero hindi siya ganun kaganda kagaya ng ionic bonds ng covalent and electrostatic. Okay? Covalent ang pinakamaganda because they share electrons. Ano na yan? Chemistry yan, di ba? Okay? So, ginagamit pa rin dito. So, you can also have your van der Waals, yung sharing. Okay? Yung electron cloud. So, nuclear staining, it's not fully understood. There are basically two patterns. One is stained done with basic dyes. Okay? Hematoxylin is a basic dye, tama? And nuclear staining, ano ba laman ng nucleus? Chromosomes. Ano bang components ng chromosomes? Di ba? Deoxyribonucleic acid. Class, acid siya. So, ang kukunin niyang stain ay basic. Nagets siya? Simple lang, di ba? So, staining done with dyes combined with the following metal mordants. So, ba't nilalagyan ng metal mordants? Para mag-stick yung stain sa loob ng nucleus. Kaya nilalagyan ng mordant para mag-stick sa loob, para hindi umalis. It bridges the gap between chemical cell components and the stain. Nasa gitna ang mordant. Pinagdidikit niya. Okay? Those are mordants. How about cytoplasmic staining? This is basically called non-nuclear staining. Kailangan niya na ito, IEP or isoelectric point. Why? Because ang ini-stain mo rito is amino acids. Ang amino acids, di ba nagpapalit ng charges? Pag nilagay mo siya sa basic, nagiging ano siya? Pag mababa ang pH, nagiging basic siya. Pag mataas masyado ang pH, nagiging acidic siya. Di ba nagkakaroon ng amino acids? Kaya nga mayroon tayong tinatawag na isoelectric point. Wherein, walang positive or negative charge, therefore walang migration. It's called the isoelectric point. Ano nito? Tinatawag natin sweeter ion. Hindi pa rin. Anyway, let's go on. Kasalanan niya. To understand the staining of non-nuclear elements, dapat maalala niyo ang pH. Okay? So, pakita ko sa inyo. So, tingnan niyo ito. This is your sweeter ion. This is the amino acids of proteins. If the pH is very low, the amino acids become basic. If the pH is very high, it becomes acidic. Nagkas niyo na? Nagkas niyo? Alam niyo yung mechanism din? Nalala niyo na? Hindi. Pero naintindihan niyo, tama? Hindi niya na may resyon na yan. Sige. Kasi electron donor lang naman yun, di ba? If your pH is 1, madami kang hydrogen. Tama? Magiging donor ng hydrogen to. So what happens? Donate niya yung hydrogen, magiging basic. pH na kasi niya. Dito, electron acceptor to. So what happens? Yung hydrogen dito, yung pinakamahinang hydrogen, kukunin. So magiging acidic. So COO lang siya. Ano niya yan? That's? Okay? The IEP, the isoelectric point of most proteins is basically pH 6. Okay? And below this, the net charge is positive. Therefore, pag nag-positive yung charge ng amino acids, magiging positive siya, ano kukunin niya nga, dye? Negative. Tama? Tama? Kasi ba? So above this, the charge is negative. Therefore, ang kukunin niya ay positive. Nagkats siya? Lalabas ko sa exam niya para magkandalaw-dalaw ka. If the tissue is placed in a solution of pH, the cytoplasmic protein will develop a predominance of positive charges and will attract negatively charged dyes. Eosin. Kaya yung eosin napupunta sa cytoplasm kasi yung pH naging 6. No? Below 6 pala, therefore magiging basic. Anong kukunin dye pag basic yung substances sa loob ng cytoplasm? Acidic. Ang eosin mo is acidic, di ba? Tama? Okay? So, talagang simple lang. Okay? All dyes are organic compounds and most are coal tar or benzene derivatives. Okay? So, we have what we term your chromophore. It's a group that confers property of color. Okay? Ang mga groups na yan ay carbon to carbon, carbon to oxygen, carbon to sulfur, carbon to nitrogen, 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 and nitrogen to oxygen. And sometimes nitrous oxide too. Okay? The more of this occurs, the more pronounced the color. Kasi siya tinatawag na chromophore. Okay? It confers the property of color. Okay? A benzene derivative containing chromophobic groups is called a chromogen. Basta may benzene derivative. Okay? Therefore, the dye, you also have your oxochrome. This is an ionizing group. Required the dye to link to the tissue para mag-bridge din. Oxochrome ang tawag. Okay? Kaya yung more than. Tama? Meron tayong more than, meron tayong oxochrome. Kasi ang more than, gagawin niyang complex para hindi, pag nag-wash ka, hindi lalabas ng cell. Tama? Yun ang more than. Ang oxochrome naman, nililink niya. Covalent bonding. Okay? Para hindi naman ma-wash out. So you have your basic type, aniline dyes, and your acidic type, or sulfonic yan. Okay? Mga oxochrome. Remember this one? Di ba part 2 ng ano? Amino, aniline. Okay? So the dyes, the basic dye, charge on the dye ion is therefore positive. Okay? Therefore called cationic. It's positive, so cationic. Therefore, ang probable na kasama ng ion is your NH2, therefore it's an oxochrome ng basic dyes, NH2. Ano yung sabi niya? Anong oxochrome? An ionizing group. Ang basic is NH2, aniline. So therefore, sa basic dyes or aniline dyes, you have your NH2, and they're basically called cationic dyes. Okay? Sa acidic type, negatively charged siya, so anionic siya. Okay? So have your sulfur type, your COOH type, carboxylic type, and your hydroxyl type. Okay? Okay, some dyes are basically amphoteric and are cationic if the pH is below the isoelectric point, or anionic if the pH is above the isoelectric point. Example nito is your hematine. So meron ding mga dyes na kagaya ng proteins. Di ba? May proteins tayo na pag bumaba ang pH, naging positive. Tama? Na pag tumaas ang pH, naging negative. Ganun din, yung mga dyes na ganun din. Example, itong basic dye mo, pag bumaba, naging positive. Pag tumaas, naging negative. Okay? So, sumusunod siya sa isoelectric point. Pansin niyo ba? Importante yung isoelectric point. Sumusunod siya. Okay, so what factors affect dye binding? One is the pH. Siyempre, sabi siya kanina, di ba? Pag positive isa, negative isa, magdidikit. Okay? What else? Temperature. Why? Because it causes swelling. Okay? Increased temperature or penetration. Namamaga ang cells pag mataas ang temperature. Bakit? Di ba ang water kapag pinakuluan nyo, nag-expand? O tinaas yung temperature, nag-expand. Napansin nyo ba yan? Ha? Napansin nyo? So same thing here. Ang cells natin merong, hindi naman water, fluid content. Na pag tinaas mo yung temperature, mag-i-increase yung, gagalawang atom sa loob, di ba? Mag-i-increase ang size. Okay? So what else? It also is dependent on concentration. So temperature, concentration, pH. Okay? Factors affecting dye binding. You have your concentration, pH, temperature. Ano pa? Salts. Ang salts, okay, it can decrease or increase staining intensity. Okay? Ang salts pandagdag ng ions. Okay? Now, depende kung saan mo gusto puntahin yung ion. Papunta sa positive, papunta sa negative. Di ba? Ionic nga eh. Lalakoy mo yung ions eh. Okay? So, salts are also important. Fixatives. Ang isa pa. Okay? Tingin nyo ginagawa ng formaldehyde. Okay? It reacts with the amino group, making the unavailable for dye binding. So, pag napapansin mo, lahat ng in-stain ng formalin, lahat ng binabad sa formalin, hindi na nakakapag-participate yung amino group ng cytoplasm. Kasi, di ba, ang tendency ng formalin, i-fix siya. Tama? Pag nag-fix ka, sisirain mo ang mga proteins. Tama? Baka masira mga enzymes, baka hindi masira ang cells. So therefore, pag sinira mo siya ng formalin at in-stain mo ng, you try to stain it with dyes, hindi lahat ng proteins na nasira may stain. Nagets niyo ba? It's because sinira ng formalin. So, I think that you have to expect that kapag ikay gumagamit ng formalin, your tendency of destroying cellular structures nandun din. Okay? Nandun din. Nakita niyo bang nakita niyo bang effect ng formalin? Talagang sisirain niyo yung enzymes para hindi masira yung cells, para hindi mag-necrosis. Right? And those enzymes are also stainable. May stain din siya. Okay? Now, come to think of it, ang formalin, ina-adjust din ang pH. Kaya ang ginagawa natin ngayon, 10% formalin, ang 10% buffered formalin, di ba? Ang sinasabi, 10% buffered formalin. Kasi otherwise, if you do not buffer this formalin, mapuform ka ng salts. Salts. Ayun na, may salts, di ba? Mapuform ka ng salts. Aldehyde kasi siya eh. Nanigets siya pa, class? Chemistry na to eh. Anyway, bahala kayo sa buhay niya. Differentiation, you can have your progressive staining. Okay? Kung gaano kagandang staining ang gusto mo. You can also have regressive staining. Lalo na pag na-overstain. Okay? So, mordants, usually substances or metals that link between dye and tissue. Okay? Usually a basic in action and must be used regressively. Kunyari, naglagay ka ng mordant, dahan-dahan mo hugasan hanggang mawala yung mordant. Okay? Ano bang ginagamitan ng mordant? Nag-micro na ba kayo? Tapos na kayo sa AFP? Staining? Acid fast? Ha? Ano? Wala pa? Hindi kayo acid fast staining? O acid fast staining uses iodine as a mordant. Okay? Mordant ang iodine. Mordant siya sa acid fast. So, methods of differentiation, meaning when mordants dyes are used, example natin ay acid fast. So, cationic dyes are differentiated by weak acid. Okay? Example, aluminum hematoxin can be differentiated by hydrochloric acid. Plus, ito mga technique na to ng mga advanced na medtech. Yung alam na nila kung sobra ako sa kulay or sobra intensity, hindi mo gusto ng pathologist, ginagamit ito mga technique na to. Again, ang concept niya, base and acid lang. Pag basic ang ginamit, panghugas mo, acidic. Okay? Hindi to, at least a dilute solution of hydrochloric acid. Talagang papatakan mo yung slide hanggang mabawasan yung kulay. Okay? Mga techniques na to. Now, acid can be removed by ammonium hydroxide. Basic siya. Tama? AUC is acidic. Ang tanggal mo sa kanya is basic. So nakita niya, style na yan. So excess mordant will break the tissue mordant dye complex. Okay? Now, sections stained with regressive iron hematoxylin are differentiated with excess mordant. So kita nyo, pati yung techniques, kunyari na sobrang blue, masyadong dumikit, lagyan mo dagdagan mo ng mordant, mabawasan yung pagka-blue niya. Kasi ang tendency ng mordant mo, break the tissue mordant dye complex. Aagawin niyo yung ibang stain, lalabas. Nagis niya? Mga techniques na to, class. Techniques ng magandang slide. Okay? So una, you could use differentiating medium like your alkaline and acidic solutions. What else? You can use excess mordant para gumanda yung slide mo, differentiating. Okay, oxidizers, pwede mong gamitin. Example, potassium permanganate and chlorine trioxide. I-oxidize mo. Okay? Kasi ang technique ng H&E, di ba ang hematoxylin mo is supposed to be oxidized para maging maganda? Nalala niyo yun? Alam niyo yung sabihin na, yung anyway. Yung hematoxylin nyo kasi, pag tinimpla yan, kailangan, dalawang klase ng hematoxylin. You have your Harris and yung Weikert, tama? Ha? Yung Harris hematoxylin mo, it's supposed to be exposed to air. Kailangan siya ma-oxidize. Kailangan siya maging hematine para mag-stain. Ang bagong gawang hematoxylin, hindi magandang stain. Kailangan ma-expose to air. Nagets nyo? Ayun, basahin na lang. Sometimes, para bumilis yung oxidation ng hematoxylin to hematine, nilalagyan ng oxidizers. Kunyari, kakatimpla mo lang, nahuli ka na ng pathologist, wala lang na hematoxylin, gumagawa ka pa lang. Nakalimutan mo mag-prepare. Hindi pa na-expose sa hangin, tama? Lalagyan nila ng potassium permanganate para mag-oxidize, para magamit agad. Gets? Gets? And class, hindi porket meron kang oxidizers, what you do is i-oxidize mo ba yung hematoxylin yung sagad-sagad. Remember, it will always be exposed to air kada tanggal mo ng takip, kada husaw mo. Okay? So, continuous process of oxidation ng hematoxylin. Technique na to, class. Hindi na to simpleng microtome lang. Okay, nakamove na tayo sa microtome dito. These are techniques used para maganda yung slides. Ibig sabihin, class, kahit nagkamali ka, pwede mo palang iligtas yung slide. Right? So nuclear dyes, hetoxylin is basically the most widely used. Okay? So oxidized dye is hematine, a weak anionic dye. Okay? Tignan niya, galing ka sa hematoxylin campesianum, which is freshly cut, is colorless but becomes dark, reddish-brown when exposed to atmospheric oxidation. So tuloy-tuloy yan, class, in hematine formation. So what does it look like? So ito hematoxylin mo. Okay? Nakita niyo itong hydrogen na ito? Na-oxidize siya. When you say oxidize, remove the electron. Tama? Tingnan niyo rito. Asa na? Ito na. Hematine na siya. So ito yung area na reactive para dumikit sa cells. Okay? So oxidation of hematoxylin, what we call your ripening. Okay? Ripening. Necessary to convert it to hematine and may be achieved through Ehrlich solution, atmospheric oxygen, which we call your Ehrlich solution, or using your potassium permanganate called your Harris hematoxylin. So yung mga pangalan siya, di ba? Okay? Now, solution should always have some unoxidized hematoxylin because ripening continues with atmospheric oxygen. Nagets yun na? Eventually, pag sumobra ng tagal yung hematoxylin, nagiging flakes naman. Sobrang ripening na yan. Okay? So hematine has still affinity for tissues. Mahina siya eh. So what we do here is use a metallic mordant to bridge the gap between the dye and the tissue. Tama? So therefore, Harris hematoxylin contains ammonium aluminum sulfate. Nagets niya? Remember, hematine is a weak anionic dye. Ang dinagdag niya, metallic mordant, tapos nilagyan niya pa ng ammonium aluminum sulfate. So ano ibig sabihin nun? Pinababind niya talaga. Kasi ammonium is what? Basic. Ano yung hematine? Weak anionic. Therefore, magdidikit yung dalawa. Nagets niya na? Okay? Nagets niya na kung bakit kahit acidic yung dye ng hematine, didikit pa rin siya sa metallic mordant kasi merong ammonium. Tama? Okay? So, more selective nuclear scaling can be achieved by either excess of acid or excess of aluminum. Yun na. Lalakuin mo na yung hydrogen at yung metal. Okay? So, hematoxylin, ito ang laman. Okay? Absolute alcohol. May mordant siya. Tinuro na ba sa inyo ito? Sa lab, di ba? Sausaw lang, sausaw. Alam nyo na. Yung naman yung sinasusawan nyo. Okay? Tingnan nyo, meron siya oxidizer din. Okay? So, preparation of Harris hematoxylin, of course, sa alcohol, so on and so forth. Sa lab dapat din. Okay? Nilalagyan mo ha. Nilalagyan ng acetic acid, right? Para saan acetic acid? Di ba lalakoin mo nga yung dye? Pag basic siya, lalagyan mo ng pag nag-oxidize siya, babawasan mo naman ng acid. Tama? Lalakoin mo talaga yung pH niya eh, kahit anong gawin mo eh. Okay? So the use of Harris hematoxylin, okay, can solution be used, acidified, or diluted as a progressive state. Lahat-lahat. Okay? So 1 to 3 minutes will give good nuclear staining consistency. Okay? How about cytoplasmic stains? Ito yung AUC. Okay? So most frequently anionic, negatively charged. This is yung AUC. Combined with very cationic positively charged tissue groups. So, pag ionic, anionic siyang stain mo, ang kanyang stain ay cationic. Negative yung stain, positive ang i-stain niya. Positive ang stain, negative ang i-stain niya. Gets niya? Okay? Ganun pa rin. So, most frequently, basic amino acids such as arginine, histidine, and lysine are common sites for binding. Amino acids niyan, ha? Pinag-uusapan natin. Ano ba ang arginine, histidine, and lysine? These are basic amino acids. Nai-stain siya ng anionic, okay? Or negatively charged. So, magdidikit talaga sila, right? Different charges attract, same charges repel. Tandaan niyo yan. Okay? So, ito yung laman ng iusin niya. May acetic acid pa rin, glacial. Okay? So, most widely used, counterstain siya for routine sections. It's a sodium salt of color acid. Okay? The chromophore is a negative part of the molecule. Negative. So, iosine tetrastain is fully charged at 7. Because IAP is 6, we must stay below 6. Tandaan niya, yung 6 ang importante dito, yung pH niya. Kasi yung IEP mo, yung isoelectric point. Kasi, pag yung stain mo, nilaro mo masyado, naging acidic masyado, ano mangyayari? Ano mangyayari? Masyadong acidic yung stain. Magiging basically proteins, right? Nalala niya? If the pH is less than towards 1, magiging basic yung proteins. Tama? Ha? So, ano mangyayari ngayon? Basic yung proteins, acidic yung stain. Pag pinagsama mo, anong kulay? Tissue. So, bakang pink. Nagets niya? Ulit. Negative stain. Mataas ang pH. Tama? Mababa pala, sorry, acidic siya, mababa ang pH. Therefore, acidic, mababa ang pH. Ano mangyayari sa protein mo? Positive o negative charge? Gumalaw tayo sa side na to. Ulit. Acidic ang stain. pH is towards 1. What happens to your proteins? Acidic o basic? Basic. Right? Basic proteins will attract what? Acidic or basic dyes? Acidic. Therefore, what will be the color of the proteins? Pink or blue? Pink. See the point? That's why lalagay nyo yung stain. Lalagay nyo sa 6 because the isoelectric point, meaning to say, proteins, amino acids have no charge at 6. So, makukuha mo siyang tama ang kulay. Kung sino ang basic, mag-basic siya. Kung sino, nagigit siya? Gano'n kayo importante yung isoelectric point? Nagigit siya ba, class? Yes. Ooh. Okay, tignan nyo. pH 4, AUC is converted to free acid. Tignan nyo na. May remain solution, bind to such making appear muddy. Papangin talaga. Okay, the best staining agent occur at pH 4.6 to 5. Okay? So use at least 3 shades of pink. Tandaan nyo, ang pinakamaganda, erythrocyte should be deepest pink. Next is collagen and muscle. Okay? Collagen and muscle and epithelial cells. Di ba puro pink sila? Alam nyo na? Or hindi nyo, anyway. Plus, ito meron ng kasamang quality assurance to. Yung ginagawa nyo trabaho, dapat alam yung kulay. May gets nyo? You're supposed to know what color you're doing. Hindi lang pag sinabi sausaw lang kayo. Okay? So, what you'll notice here is bluish ang nucleus. Tama? Pinkish ang cytoplasm. Tignan nyo to. Ano napansin nyo? Ang pangit ng stain. The nucleus looks smudgy. Right? Look at the cytoplasm. Tignan nyo yung pagkakapink. Look at the pink nature of the cytoplasm compared to this one. Okay? So that's staining lang yan, ha? Pareho yung pareho yung tissue. Okay? You notice? Sa staining ito problema. Okay? So H and E, the nucleus should be blue, the erythrocyte should be bright pink to red, the cytoplasm should be various shades of pink. Why? Bakit various shades of pink ang cytoplasm? Yung na doon lahat ng proteins. Tama? Tama? Nandun lahat ng proteins. And hindi naman lahat ng proteins negatively charged. May positive, di ba? Diba? Kaya nga may lalagyan natin ng sweeter ion. Okay? So, hints to help achieve, okay, lagi nyo gagawin. Microscopically check the slide from each basket. Okay? Bilang medtech, dapat alam nyo yan. Do not allow sections to dry. Drying the sections, hindi makukuha ng stain. Andyan nyo, do not let sections dry. Keep solutions covered but not in use because of evaporation. Okay, develop a routine schedule for changing solutions based on the number of slides each day. Kunyari, Dok, 100 slides. Pag sinausaw dyan, di na pwede gamitin yan. Okay? Although, ideal yon sa gobyerno, hanggat hindi pangit yung hindi papalitan. Okay? Pero dapat, may alam mo na, kunyari, 100 slides, papangit na yung stain. Okay? After applying ammonia water, wash the sections very well with tap water. Okay? Remember, the pH of acid is critical. If too much ammonia is carried over into the acid, mawawalan ka ng cytoplasmic staining. Remember, ammonia is basic acidic. Basic. Ayusin is basic acidic. Acidic. So, pag hugas mo, pag sobrang pink is ammonia. Okay? So, do not pass the slide through dehydrating solutions too quickly. Okay? Although remember that more dilute the alcohol, the more eosin will be removed. Okay? Tissues that have been fixed for longer than normal may require increased staining times. Yung tipong 20 years, tatagal mo ang staining na, para mas matagal. Kasi eventually nag-evaporate naman eh. Okay? Staining times may be adjusted depending on the fixative used. If tap water in the area has no other color, ito, hindi nyo ginagawa to. Kasi, napansin ko yung mga medtech, basta may tubig, tap water, ganun na. Ang tanya, tap water, madaming metals, may mga components siya. Okay? May chlorine nga siya. Okay? Remember that what appears to be a staining problem may not be a staining problem. Pwedeng problema sa fixation, processing, carry over, so on and so forth. Ano nga ba yung most important step? Fixation, ha? Okay, fixation. Good. Okay? So, ang ganda, di ba? Ito, lymphocytes to. Ganda, tingnan nyo itong RBCs. Okay? Kumpara nyo ito sa next. Pangit, ano? Okay? So, sobrang pink, right? Sobrang pink, kumpara sa isa. So, ano bang mga problems natin with H&E? It could be incomplete deparaffinization. Hindi mo natanggal lahat ng paraffin. Okay? Nuclear staining is not crisp. Pale nuclear staining, dark nuclear staining, red-brown nuclei, pale cytoplasm, dark cytoplasm, so on and so forth. Okay? Pwede uneven, poor contrast. Lahat yan, checkin nyo. Mag-i-start ka ulit sa fixation. Checkin mo kung saan ka nagkamali, sa infiltration. Okay? Nagaya niya. Incomplete deparaffinization. Ito natin, di ba? Yun yung paraffin, no? Okay? Nuclear staining, not crisp. Tignan yung nucleus, smudgy. Okay? Hindi maganda pagka-nucleus. Pale nuclear staining, ano yung nucleus? Putla. Okay? This could be na sobrang ka sa pag-wash. Okay? Pwede na sobrang ka sa wash. Dark nuclei, nasobrahan sa pag-stain. Pwede. Okay. Red-brown. Red-brown, usually, ang ano mo nito, ang hematin is paluma na. Naluluma na yung hematoxylin mo. Kasi di ba, once na-oxidize ang hematin, magka-clamp-clamp yung maging flakes. So wala nang stain na nakadissolve dun sa sa solution. So once you stain them, ang pangit na. Okay? Wala na. Red-brown nuclei. Or nasobrahan ka na sa ripening. Pwede. Okay? Okay, cytoplasm. Hindi maganda ang ayusin mo. Okay? Okay, dark cytoplasm. Sobra. Sobra sa babad sa ayusin. Okay? So, hindi na differentiate ng maayos ang ayusin. Ganyan to. Red blood cells to, di ba? Tingnan niyo yung cytoplasm ito. Halos pare-pareho kulay. Okay? Okay. Glomerulus yan. Okay, blue-black pigments. Ayan o. Linisin mo ang hematoxylin everyday. Kasi yun yung hematin. Pag nag-oxidize, may flakes. Okay? Uneven staining. Ayan. Sometimes ito, area na to, adequate ang water, adequate ang hydration, ito sobrang dehydrated. Okay. So poor contrast between nucleus and cytoplasm. Halos pareho lang yung kulay, di ba? Pink na rin yung nucleus. Okay? Ayan, hulaan ako niyan. Ha? Nung inooperahan gumamit ng cautery, yung pangsunog ng balat, yung pangsunog ng laman, ayan o, sunog din. Hindi nyo na matatanggal yan. Ano na yan? Artifact yan. Kasi di ba minsan kasi ayaw ng Dr. Blade. Kasi bloody. Gagamitin nila pa ng opera, siya cautery. Kasi ang cautery, habang while you're cutting, you're also destroying blood vessels. Binapasok ang straight mo. So sumasara yung blood vessels. So, karamihan ng cauterization, walang halos blood. Okay? Pero, sunog naman yung tissue. Okay? Kahit anong ganda na stain mo, sunog pa rin yung tissue. Okay? So that's for your staining with HME. Okay? Now, you also have, after your staining, you have your mounting stain solution. So, okay na to. May lang to class. So, dalawang klase ang pang-mount mo. You have your aqueous and your resinous. Ang ginagamit natin ay resinous. Okay? So, ang resinous natin is yung masarap amoy, yung Canada balsam. Amoy nyo na to. Para siyang, di ba? Para siyang Gabi. Okay? And Gab du Mar. Okay? Ang maganda sa kanya, hindi siya na-apektuhan masyado ng prolonged storage. Okay? And often ang ginagamit natin pang dilute is toluene. It's better than your xylene. Therefore, mas mabilis mag-evaporate ng toluene kaysa xylene. So, the faster the toluene dissolves, the more likely you'll have gas bubbles. Okay? Pag mabilis mag-evaporate, mas mabilis magka-bubbles din. Okay? So, refractive index, this is actually very important class. Kasi, if you're using resinous media, the refractive index is 1.5 to 1.4. Okay? And most synthetic resin is 1.51 to 1.55. Ano ba yung refractive index? Kung gaano kaganda babalik sa yung image. Remember, di ba, when you look at microscopes, you'll notice it is actually bombarded by light. Tama? And you want to, the one thing you always want to know is that if pag tinamaan ba siya ng light, yung light ba sasayaw sobra or it will reflect to another area or refract to another area. The more na maganda yung refractive index, the more focused yung specimen. Okay? Despite kahit merong, parang ganito yung class. If this is your specimen, this is the light. Remember, the light will always scatter. If it bumps into your specimen, light will scatter, right? It's all because also of the staining, right? It will scatter. So what you have to do here is you put your media above, the resinous media. What it will do is all the light thrown out will be tried to focus in the middle. Kaya nakikita mo sa eyepiece yung tamang image. Okay? You notice na kahit galawin niyo yung specimen, pag tinignan niyo yung image, napupunta pa rin doon sa eyepiece. Right? Tama? So that's your refractive index. Hindi dapat masyadong malaki yun. Kasi, kunyari, ito yung ilaw, ito yung refractive index mo, ito yung eyepiece, yung objective, nandito yung refractive index mo, masyadong sumasayaw, therefore, hindi mo makikita ng maayos to. Okay? That's your refractive index. Okay? Aqueous medium, often gelatinous, kaya ginagamit nila. Used when dehydrating and clearing will adversely affect the stain. Okay? And yung aqueous, when dehydrating and clearing will affect the stain. Why? Because if if you're using aqueous mounting media, mayroong effect ng silane. Remember, I told you, pag water and silane nag-mix na namumuti, right? Okay, namumuti siya. So this one has a refractive index of 1.41 to 1.43. So hindi nalalayo, right? So 1.5. Okay? So troubleshooting, you can have your water bubbles. All areas of the section cannot be brought into focus. Corn flaking. Mounted sections are not crisp, and retracted mounting medium. Yung retracted mounting medium, once nag-dry siya, umaangat, lumalayo yung cover slip. Nangyayari yun. Okay? So, water bubbles. Ito yan. Daming water bubbles. So, mas maganda. Ito yan. Okay? Water bubbles. Nangyayari yan. Okay, water bubble sections are completely dehydrated prior to clearing in silane or silane substitute. Okay, so what to do here is change all the hydrating solutions, remove the cover slip and mounting media, return to fresh absolute alcohol. So repeat dehydration. Okay, so how about this one? All areas of section cannot be brought into focus. Okay, dito niyan. Alam niyo pag nangyari dyan? You know what happened here? Wala nyo ka nangyari. Di ba naglalagay, usually, you put the mounting media in between the cover slip and the slide, right? Nangyari hindi, umakit, nalagyan mo sa ibabaw dito, hindi mo napansin. So nangyayari, kahit anong gawin mo, hindi mo focus itong area na ito. Kailangan dinisip mo yung mounting media. Okay? Nakita na, difference? Mounting media yan, kasi ibabaw ng cover slip. Okay? So, mounting media on top of the cover slide. So, tanggalin mo yun. Okay? So, how about this one? Corn flaking artifact. Drying artifact. Okay? And what happens here is that when sections are allowed to dry before mounting, yung masabi ko sa inyo, huwag dry na dry. Kailangan ilang percent na, ilang percent ng water dapat meron? 2%. Yeah? Very good. 2%, very good. So what happens here is that granular brown stiffly assembled pigment or glossy black nuclei. Again, repeat means process. Dehydrate, then dehydrate. Okay? Mounted sections are not crisp pag masyadong makapal yung mounting media. Okay? So, ito yung ito yung mounting media. Nasaan ang dyan? Nasaan ang normal dyan? Ito. Nasaan area may mounting media? Which one? Hindi. Ito ang may mounting media. Nag-retract eh. Diba? Remember I told you, if you put the mounting media, gaganda ang refractive index, right? Tignan mo yung refractive index nito. Hindi mo ma-focus yung cells na maayos, right? So what happens, this is the mounting media, it has retracted pababa. Okay? So hindi ma-focus ng maayos ito ngayon because of the refractive index. Umangit. Ito maganda refractive index. This one, no. So the mounting media is here. Okay? Kala niyo ito? Anyway. Okay? Warp covers glass, mounting media has been cleaned too much by silane. Okay? Tanggalin ng covers glass. Okay? That's it. So class, any questions? Tapos na. Oh. Tapos na kayo. Tayo sa lahat ng subject ng ano. Pakuha naman yung Teka. Ako na lang. Ano kayo si Mang Tina? Ano ba?
Ay, papunta pa lang po kanina eh. Nung pumunta ko talaga.
Ano siya?
Office. Wala pa po.
Wala!
Sabi ni Ma'am Jean po, papunta pa lang.
Papunta pa lang. Sige, punta ako na lang siya. I-quiz kayo, ayos na kayo.
Sabi.